All right, so we're going to review some problems from chapter 10. So here's my suggestion. My suggestion is before I actually do them, you pause the video, see if you can do them yourself, and then you can play the video or skip ahead to see if you got the problem right. So let's go over a few examples. All right, so here are 3 examples. Problem 1. Now, the directions for all of these are just to simplify. So in problem 1, we would follow the rule of powers, and we would multiply powers, and we would get b to the negative 8, c to the second. And then we would simplify that using our rules for negative exponents, and we would get c squared divided by b to the 8th, and there's my answer. In number 2, we would take everything to the second power. So negative 4/5 squared is 16 25ths, a squared. And lastly, since we have a negative power here, that would go to the top. We would get x to the 5th because 2 minus negative 3 is 5. Or you could say x squared multiplied by x to the 3rd gives us x to the 5th. And then on bottom, I have to cube 2y. So that would give me 8y to the 3rd. And there's my answer. In numbers 4, 5, and 6, we're going to simplify the expression and then plug in our value of x to see what the value of our expression is. So I want to know what the value of the expression is. The number one step, you can do this, but I would not recommend it because it's going to be a lot more work, is to look at this and say, okay, I need to simplify this. Do I plug in the negative 1/3 first? No. You simplify. So in number 4, I would get x to the negative 3rd squared, which would give me x to the negative 6th. Then that would give me 1 divided by x to the 6th, and now I plug in my negative 1/3. So that would give me 1 divided by negative 1/3 to the 6th power. Now we have to take negative 1/3 to the 6th power, and negative 1/3 to the 6th power would be 1 divided by 1 7/29. Now, following our rules from elementary school, we would take 1 divided by 1 7/29. I have to multiply by the reciprocal, so 1 multiplied by 7/29 would give me an answer of 729. Number 5, I multiply with the same base, so I add the exponents. I then plug in my negative 1/3. Make note that you have to put parentheses. If you write this, it is not the same thing, because this is just 1/3 squared. This is negative 1/3 squared. So negative 1/3 squared would give me positive 1/9. Number 6, I have negative, and then I take everything square. I simplify inside. So x to the 3rd multiplied by x to the negative 4th is x to the negative 1. I multiply powers. That gives me x squared. That gives me negative multiplied by negative 1/3 squared, which would give me negative 1/9 as my final answer. Our last 2 problems, number 7 and 8, I want you to simplify. In this problem, number 7, we would first take everything squared and everything to the 3rd power. Well, if I took 5y to the 3rd squared, that would give me 25. I leave it in parentheses because I'm still multiplying. W squared, I take 1 times 2, that's how I get the 2. 3 times 2 is 6, so I get that. Multiply by negative 2 to the 3rd, which is negative 8. 1 times 3 would be w to the 3rd. 2 times 3 would be y to the 6th. I now multiply what I have left. 25 multiplied by negative 8 is negative 200. W squared multiplied by w to the 3rd, I add the powers. And y to the 6th multiplied by y to the 6th is y to the 12th. And there's my answer. In number 8, divide by the same base, I subtract the powers. So 4 to the 9th divided by 4 to the 7th is just 4 squared. Divided by 5 minus 7 is a to the negative 2, which will give me a squared on the bottom. I simplify that, I get 16 divided by a squared. All right, we're going to do one more. I want you to simplify this. In this problem, I start with 5/10. I simplify 5/10 into 1/2. I then can subtract my powers here. There are a couple ways you can do it. But if I take -7 minus -4, that's -7 plus 4, which gives me -3. So I get a to the -3. And then 3 minus -2 is 3 plus 2, which is b to the 5th. But I can't have that negative there, so it's going to go to the bottom. So my answer is going to be b to the 5th divided by 2, a to the 3rd. All right, one of your standards is not only knowing scientific notation. So I'm not going to review just basic scientific notation. I'm going to make it obviously a little more difficult. But one of your standards is knowing how many times bigger something is than something else. So if I gave you a problem that looked like this. So here are two numbers in scientific notation. I want to know how many times larger is the bigger number than the smaller number. Now I'm not asking how much greater, I'm asking how many times greater. So we obviously have to do division as the inverse operation. So we have to figure out which one of these numbers is bigger. Well, because 10 to the 11th and 10 to the 9th, this is going to be multiplied by 10 more times. 1.12 times 10 to the 11th would be a bigger number. So I have to divide 1.12 times 10 to the 11th divided by 5.6 times 10 to the 9th. Following our rules of a division, you would take 1.12 divided by 5.6. So that would give us 0.2. And so when you take 1.12 divided by 5.6, we get 0.2. But remember, if I'm dividing powers, what do I do with the exponents? Since they have the same base, you'd subtract them. So that would give me 10 squared. But is that in scientific notation? No, 0.2 is not in scientific notation. So my answer would be 2 multiplied by 10 to the first power, or just 2 multiplied by 10. And the problem is, though, is the question asks how many times bigger. So you wouldn't say 2 times 10. You would say what? Oops, not approximately. You would say it is 20 times larger. And there's your answer. All right, let's add and subtract two numbers in scientific notation. All right, so in problem number 11, we're going to subtract these two values in scientific notation. So in scientific notation, you can subtract them if they have the same power to the base of 10. And in this case, they do. So you just subtract 5.6 minus 3.1, and we get 2.5 times 10 to the 5th. And we are done. It's that easy. So now let's look at number 12. We need to add these together. But first, we noticed that the bases do not have the same exponent. So we need to make them the same exponent. So what I'm going to do is I'm going to make them, let's do, which one do I want to change? Now, it doesn't matter which one you want to change. You could change either one. But let's do, I'm going to change the first one. So I'm going to make it to the 10 to the 9th. Well, 10 to the 9th times what gives me 10 to the 8th? Well, it would be 10 to the negative first. So I have 4.2 multiplied by 10 to the negative first, multiplied by 10 to the 9th. All I've done is rewrite 10 to the 8th as 10 to the negative first multiplied by 10 to the 9th. So that gives me 0.42 times 10 to the 9th plus 5.9 times 10 to the 9th. I now add them together, and I would get 6.32 times 10 to the 9th. And your final answer is between 1 and 10, so therefore our answer would be just that, 6.32 times 10 to the 9th.